Hello friends and my dear students, I welcome you all to my channel. I hope you're all doing well and your studies are also going on well. This is in this part 11 video from the chapter of Heron's formula. I will discuss about the area and perimeter of a trapezium. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma, where I primarily discuss about the key concepts and formula for problem solving. If you find this video beneficial, then please like it, share it with your friends. And once again, please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so there are basically three concepts of finding the area of a trapezium that we will discuss. The first one is to find the area based on the lengths of the parallel sides and the perpendicular distance between the parallel sides. Now, the perpendicular distance between the parallel sides of a trapezium is known as altitude. So, let's say ABCD is the trapezium where the parallel sides are AD and BC. Now, so the perpendicular distance between the parallel sides AD and BC I can draw will be the perpendicular drawn from the vertices A and D on BC or perpendicular drawn from the vertices B and C on AD. So, let's say AO is perpendicular to BC. So, AO will be the altitude of this trapezium or the perpendicular distance between the parallel sides AD and BC. So, let's say the length of AO is H. So, this is the length of the altitude of the trapezium is H and the length of the parallel sides are X and Y. So, then the area of the trapezium will be let's see how we can so the formula is half into the sum of the parallel sides multiplied by the perpendicular distance between the parallel sides or the altitude of the trapezium. This is the formula. So, how this formula is coming? Let's quickly see the concepts behind of this formula. So, it is based on the area of triangles. So, if I join A and C, the diagonal AC. So, AC is the diagonal of this trapezium ABCD. Now, we can say that the area of this trapezium is equal to, we can say it is area of the triangle ABC plus area of the triangle ACD, because the diagonal of a quadrilateral divides the triangle into two triangles. The diagonal of a quadrilateral divides the quadrilateral area into two triangles. Okay. Now, please note that so AO, that is the altitude, AO will be the altitude of the triangle ABC based on the sides BC. Also, AO will be the altitude of the triangle ACD based on the sides AD. So, in triangle ABC, so what will be the area of the triangle ABC? BC, considering BC as the base, it is half into BC multiplied by AO is the since AO is perpendicular to BC, so obviously AO is the corresponding altitude of the side BC of the triangle ABC. So, it will be AO plus what will be the area of the triangle ACD. If we consider AD as the base of the triangle ACD, then obviously since AO is perpendicular to BC and BC and AD are parallel, so AO will also be perpendicular to AD, and since and the concept is that the triangle ADC is the base is AD and the vertex C is on the is lying on the side BC, which is parallel to AD. So, AO will also be the altitude of the triangle ACD considering AD as the base. So, its area will be half into AD base multiplied by AO. If I take half AO by 2 as common, I have AO by 2 multiplied by BC plus AD. Now AO is the altitude of the trapezium, which is h by 2, and BC and AD are the parallel sides of the trapezium, so it will be x plus y. So this is how we are getting the formula that the area of a trapezium whose length of parallel sides and altitude is given is equal to half into product of the altitude and the sum of the parallel sides. Now altitude means the perpendicular distance between the parallel sides. Now obviously with these three information, that is x, h and y, we cannot find the perimeter. To find the perimeter of the trapezium, we of course need the length of all the sides. We only know the length of the parallel sides. We do not know the length of AB. We do not know the length of AB or DC. So we cannot find the perimeter. Just from the altitude and the length of the parallel sides, we cannot find AB and DC. So in this scenario, we cannot find the perimeter of the trapezium. But in general, perimeter from the basic fundamental concept of perimeter of a plane figure will obviously be AB, the sides, the length of the sides, the length of all the sides of the trapezium, AB plus BC plus DC plus AD. Okay. Let's see, next is how do we find the area of a trapezium, area of an isosceles trapezium. Now in an isosceles trapezium, the non-parallel sides, they are of equal length. So ABCD is the trapezium where AB, the parallel sides are AB and DC, and AD and BC are the non-parallel sides and they are of equal length. Let's say A. So this is the property of or definition of a isosceles trapezium. So we know the length of the parallel sides, that is which are x and y, and we know the length length of one equal side, and we know the length of the non-parallel equal sides, which is A. How do we find the area? Okay. Now we do not know the altitude. Now if let's draw the altitude of this trapezium from the vertex A. I am drawing perpendicular to DC. So let's say AO is perpendicular to DC, and also from the vertex B I am drawing a perpendicular on DC. Let's say this foot of the perpendicular be P. So AO and BP are both perpendiculars to the side DC. So obviously then ABPO will be a rectangle. Okay. Also now I will not go into the proof. Please note that the triangle ADO will be congruent to the triangle BCP. These two triangles will be congruent because in an isosceles trapezium, AD is equal to BC, and also these two angles will be equal. These two angles are equal. So the triangle ADO and the triangle BPC will be congruent. So this implies that DO will be equal to PC. DO will be equal to PC. Now the idea is that we know the length of the parallel sides x and y. If somehow we can find the length of the altitude, that is AO and BP are altitude of this trapezium. Let's say the length of the altitude be h. If somehow we can find h, then we can find the area of the trapezium using the formula half into h into x plus y. How do we find h? We will find h using one of the triangles ADO or BPC. These triangles are right angle triangles. Both the triangles ADO and BPC are right angle triangles. We will use Pythagoras theorem to find h. Since we know the hypotenuse, the length of the hypotenuse, consider the triangle ADO. But before that, one thing to note is that so we have DO is equal to PC. Now OP, since ABPO is a rectangle, OP will be equal to AB, which is equal to x. So this implies that DO plus PC will be equal to DC minus OP, DC is Y, so Y minus and OP is X, Y minus X. DO plus PC is equal to Y minus X, and also we know DO equals to PC. So this will imply that DO will be equal to OP, okay, will be equal to Y minus X by 2. Y minus X by 2 will be DO. Now, if we consider the right angle triangle ADO, we have hypotenuse square is equal to the sum of the squares of the arms, that is AO square plus DO square. So this implies AD is the one of the non-parallel equal sides whose length is small a. So A square is equal to AO. AO is the altitude of the trapezium whose length is h square, plus DO. What is DO? DO is Y minus X by 2 square. Okay, so this implies that h square is equal to a square minus Y minus X whole square by 4. This is equal to 4a square minus Y minus X whole square. Now obviously in this it is assumed that Y is greater than X. Y is greater than X. Okay, so we have this. So from here clearly we can find the value of h. So this implies h will be equal to square root of 4a square. Remember y minus x square divided by 2. So h is this that is square root of 4a square minus the difference of the two parallel sides, the difference in length of the two parallel sides, which is y minus x square, and whole divided by 2. So then the area will be equal to, as usual, half into the sum of the parallel sides multiplied by h, where h is this. So in this way we can find the area of a trapezium, area of an isosceles trapezium, where the given informations are the length of the parallel sides and the length of the non-parallel equal side. And of course in this scenario we can find the perimeter of the trapezium, which will be x plus y plus twice a, because we know the length of all the sides of the trapezium. The third method is how do we find the area of a trapezium whose the length of all the sides are given. So and the length, all the sides are of at least all the length of all the sides are unequal. So consider the trapezium ABCD, where AB, the parallel sides are AB and DC, the lengths are small a and small c, and the length of AB is small, AD is small b, and the length of BC is small d. So we are assuming that the length of all the sides of the trapezium are unequal. So how do we find then the area of this trapezium? The concept is that we have, the way I have drawn the figure, it is C, the length of DC is greater than A. So DC is the greater parallel sides. The length of the DC is more than the length of the AB. So in this scenario, what I will do is that from the vertex B, either from the vertex B I will draw a line parallel to AD, or you can draw a line from the vertex A you can draw a line parallel to BC. Both way it will be same. So I am drawing a line from the vertex B, a line parallel to AD. Let's say this line be sorry so these two are parallel. Let's say I am drawing a line parallel from the vertex B parallel to AD. Let's say so these two lines are parallel. Let's say this is E, this is E. So then ABED will be a parallelogram. Since AB is already parallel to DC, so AB will be parallel to DE, and we have drawn the line BE from the vertex B such that B is parallel to AD. So ABED is a parallelogram. So this implies we have drawn BE parallel to AD. So this will imply that ABED is a parallelogram. This is the short form of writing a parallelogram. So ABED is a parallelogram. So this will imply that DE will be equal to the opposite parallel sides. The length of DE will be equal to the length of the opposite parallel sides, which is AB, which is equal to small a. Okay. And also we will have BE equal to AD. AD we know is small b. Now in the triangle BEC, we know the length of all the sides of the triangle BEC, and we can easily find its area using Heron's formula. And so the basic concept of finding the area of this trapezium is that we know the length of the parallel sides, that is AB and DC, that is whose lengths are small a and C. So if somehow I can find the length of the altitude of this trapezium, let's say the altitude of this trapezium will be, if I draw from the vertex B on the side, a perpendicular on the side DC, let's say the foot of the perpendicular be O, then BO will be the altitude of this trapezium, and since BO is perpendicular to DC, BO will also be the perpendicular or the altitude of the triangle BEC corresponding to the base or side EC. So area of the triangle BEC using the formula half into product of the base and height will be half multiplied by EC multiplied by BO. So BO is the altitude of this trapezium. Let's say the length of BO be small h. So this is equal to EC what is EC? What is EC? Okay, what is EC? So EC is DC minus DE multiplied by BO is the altitude of this trapezium whose length is small h divided by 2. Now what is DC? DC is the length of the parallel side DC of the trapezium is small c. And what is DE? DE we have computed to be small a. So this is C minus A multiplied by H divided by 2. Okay. Now again, so this was the area of the triangle BEC based on the formula half into product of base and height. But we can find the area of the triangle BEC also using Heron's formula. This will be square root of S minus let's say the length of BE, the length of the side BE is small b multiplied by S minus the length of the side EC. EC is C minus A. EC is C minus A. C minus A. So C minus A, and finally the length of BC is D. So S minus D, where of course S, the semi perimeter of the triangle BEC, will be BE plus EC plus BC by 2, which is equal to BE is B, EC is C minus A, and BC is D. This. Okay. Now, so we can clearly find the area of the triangle BEC using Heron's formula, let's say the area of the triangle BEC be A. So then we can say that C minus A multiplied by H, where H is the length of the altitude of the trapezium, this should be equal to A, where A we have already, A is known from the Heron's formula. From here we can easily find H, that is the altitude of the trapezium. So this implies H is equal to twice A divided by C minus A. Now please do not try to remember this formula, just try to understand the concept, how we are forming the triangle BEC, that is drawing BE parallel to AD, and then how we are finding the length of the altitude of the trapezium, that is H, using the concept of Heron's formula. That is, we are equating the formula of the area of the triangle BEC using Heron's formula, and then the half into product into base, half into product of base and height. From there we can easily find H, that is the height of the trapezium. Once we know H, we can easily then find the area of the trapezium. So then the area of the trapezium ABCD will be equal to half into sum of the parallel sides, which is A plus C multiplied by H, where H we know is twice of A divided by C minus A, where capital A is the area of the triangle BEC. So this way we find the area of the trapezium, where the length of all the sides are given and all the lengths are of unequal length. And of course in this scenario, the perimeter of the trapezium will be A plus C plus D. So that is all about the area and perimeter of a trapezium. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next few videos, I will solve problems based on the area of quadrilateral and trapezium. So please stay tuned for the upcoming videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.